Hey everyone, in this video I would like to take a look at how we can determine where a function is increasing or where a function is decreasing. So to begin, I just want to think about that a little bit. So for a function to be increasing, that means that as we move from left to right, our y values are going up. That also means that for that section of our function, the slopes of the tangent lines have to be positive. Now for a function to be decreasing, it's just the opposite. As we move from left to right, the y values are going down, which also means that the slopes of the tangent lines have to be negative. Well, because we are looking at the slopes of the tangent lines, that means that we can use some of our derivative ideas to help us determine the intervals on which our function is increasing or where it's decreasing. So what I'd like to do is just take a look at a couple examples. I want to talk through this process and how we're going to find these intervals for where the function's increasing or decreasing. So my first example, I have a function f of x is equal to 2x cubed minus 9x squared plus 12x minus 5. Now the first thing I want to do is actually want to find the critical numbers for this function. So remember, a critical number is where the derivative is equal to 0 or it's undefined. Now that's going to help us out because if the derivative is equal to 0, that means that the slope of the tangent line is 0, which is going to indicate where our function changes from increasing to decreasing. So let's start by finding our critical numbers. To do that, we are going to need our derivative. So let's find f prime of x. So this is a polynomial, so I can just use the power rule on each of these terms. So our derivative, we end up with 6x squared minus 18x plus 12. Now I'm going to take this, I'm going to set that equal to 0 to find my critical numbers. Right away, I do see we have a common factor of 6 for each of these terms, so we can divide that out right away. So that's going to leave me with x squared minus 3x plus 2. And now factoring, we get x minus 1 times x minus 2, and taking both of those factors, setting it equal to 0, we have our two critical numbers. We have one at x is equal to positive 1, and we have another one at x is equal to 2. Now, because this is a polynomial, at these two critical numbers, at these points, the slope of our tangent line is 0. And as I said, because that's 0, it indicates where our function, where the slopes of the tangent lines change from positive to negative or vice versa. That also means that indicates a change from increasing to decreasing. So these critical numbers, they take our domain and it splits it up into some intervals. And now we just need to determine if these intervals are increasing or decreasing. So I'm going to use a number line test to help me do this. So our two critical numbers are going to take the domain of this function and it's going to split it up into 3 different intervals. So we have one interval that goes from negative infinity to positive 1. We have an interval from 1 to 2. And we have an interval from 2 to positive infinity. At 1 and at 2, the slope of our tangent line is 0. The slopes of the tangent lines for every point to the left of 1 are either all positive or all negative. So that means that my function is either increasing or decreasing on this entire interval. Once we get to 1, we have a slope of 0 for that tangent line, and then it changes. So now the entire interval from 1 to 2, the slopes of the tangent lines are either all positive or all negative, which means that this interval is either all increasing or all decreasing. And the same thing for our last interval to the right of positive 2. So to finish up, we just need to test these intervals to see if the slopes of those tangent lines are either positive or negative. Because we're looking at the slopes of the tangent lines, we want to test using our derivative. So I'm actually going to rewrite our derivative to make it a little bit easier to work with. So if I factor this derivative, I can factor out a 6, and then factoring that trinomial, which we saw down below, we get 6 times x minus 1 times x minus 2. So now I'm going to pick out a number that is smaller than 1. I could pick out a specific number, though I don't need to, because all I'm concerned with here is whether my final answer is positive or negative. So if I pick out a number that's smaller than 1, so if I pick out a number smaller than 1 and plug it into these two sets of parentheses here, something smaller than 1 minus 1, that's going to give me a negative number. And something smaller than 1 minus 2, that is also a negative number. So negative times a negative, I end up with a positive. So that means that all the tangent lines to the left of 1 have a positive slope, which means for this interval, it's increasing. Now let's do the same thing for the interval in between 1 and 2. So now we're picking on a number that's bigger than 1, but smaller than 2. Again, I could pick out a specific one, but I'm only concerned with the signs. So the number's bigger than 1, but less than 2. So a number bigger than 1, if I subtract 1, I end up with a positive. And in the second set of parentheses, it's smaller than 2, so if I subtract 2, I end up with a negative. A positive times a negative, we get a negative, which means that for this interval, all the slopes of the tangent lines are negative, which means that this interval is decreasing. And the last one, if we pick out a number that's bigger than 2, something bigger than 2 minus 1 is a positive, and something bigger than 2 minus 2 is also a positive. So positive times a positive, we get a positive. So that means that this interval is increasing. So just to summarize this then, our function is increasing on the intervals from negative infinity to 1 and from 2 to infinity. And our function is decreasing on the interval from 1 to 2. So there we go. So there's our intervals where our function is increasing and where it is decreasing. Let's verify this by taking a look at the graph of this function. So in my calculator, I can go to y equals, and I'm going to type in my function. So we have 2x cubed, and then minus x squared, 9x squared, plus 12x, and minus 5. Now before I graph, I'm just going to check my window to make sure that my graph is going to be in here. So we do see that we have some changes from increasing to decreasing at 1 and 2. So I want to make sure that gets contained in my window. So I'm just go from -3 and I'll go up to maybe +7. So that gives me a range of 10 units for x. Now I'm not sure the maximum or the minimum here, but we just want to ensure that we can see where the function's increasing and decreasing. So I'm going to go from, let's say, -10 to +10 in the y direction. Now if I graph this, we should see where it's increasing and where it's decreasing. So at 1, so our function is going up, it's increasing. Once we hit that x value of 1, we have a local maximum here. So a horizontal tangent line where it changes and now it's decreasing in between 1 and 2. And once we hit 2, we have another horizontal tangent line, a local minimum, and now it changes, and then the graph continues increasing all the way to positive infinity. Okay, let's take a look at one more example. We'll talk through that process one more time. So my second function, g of x, is equal to x squared minus 1 to the 2/3 power. So again, the first step, we need to find our critical numbers. So I'm going to find the derivative of g of x. I'm going to need to use the chain rule here. So we have 2/3 times x squared minus 1, subtracting 1 from the exponent, that's a -1/3 power. And now multiplying by the derivative of the inside, the derivative of x squared is 2x. Again, I'm going to rewrite this to make it a little bit easier to work with. So in the numerator, I'm going to end up with 2 times x, so that's a 4x. And in the denominator, I have this 3. And then instead of a negative exponent, I'm going to take this binomial and I'm going to move it down into the denominator, x squared minus 1 to the 1/3 power. Now to find the critical numbers, these are going to be wherever our derivative is 0 or undefined. So for this to be equal to 0, the numerator has to be equal to 0. That's going to occur when x is equal to 0. I can plug in 0, that makes the numerator 0, which makes the entire thing equal to 0. Now for this to be undefined, the denominator would have to be equal to 0. There are two numbers that are going to make that happen. So either x is equal to 1 or x is equal to negative 1. If we plug in 1 or negative 1 into the denominator, we'll end up with 0 to the 1/3 power, which is 0, which gives me something that's undefined. So here's our three critical numbers. And again, that's going to take our domain, split it up into intervals, and then we just need to test where these intervals have positive or negative slopes. So let's think about a number line test again. So we have -1, we have 0, and we have +1. So we actually have 4 different intervals in this example. So you have an interval from -infinity to -1. We have an interval between -1 and 0, between 0 and 1, and then our last interval from +1 to +infinity. And again, we're just going to test out each of these intervals to see whether the slopes of our tangent lines are positive or negative, and we're going to do that using our derivative. Again, I could pick out specific values, but I am just concerned with the sign. So if I pick out a number smaller than -1, so it's a negative number, so that means that the numerator is going to be negative. And then in the denominator, something smaller than -1 squared, that's going to turn into a positive. So that's bigger than 1. -1 is going to be a positive number. To the 1/3 power is going to stay positive. So I end up with a negative divided by a positive, which gives me overall a negative value. So that means that the slopes of the tangent lines to the left of -1 are all negative, which means that this interval is decreasing. So now let's pick out a number in between -1 and 0. It's still negative, so that means my numerator is going to be negative. And now in the denominator, something in between -1 and 0, so like a fraction, it's negative. So if I square that, it's going to turn into a positive fraction that's less than 1. And if I subtract 1, I'm going to end up with a negative number. A negative number to the 1/3 power stays negative. So overall, I have a negative divided by a negative, which is going to turn into a positive. So for this interval, the slopes of the tangent lines are all positive. Now, a number in between 0 and 1, so now we have positive numbers, which makes the numerator positive. Now, in the denominator, this is something that's less than 1, so some fraction maybe. If I subtract 1, that's going to be a negative. And then a negative to the 1/3 power stays negative. So a positive divided by a negative, we have a negative overall for that one. And then our last interval, we're going to pick out a number that's bigger than 1. It's positive, so again, our numerator is positive. Something bigger than 1 squared, that's a positive number, which ends up being bigger than 1, so -1. Our parentheses here end up being a positive number. Positive number to the 1/3 power stays positive. So we have a positive divided by a positive. So overall, we get a positive for that as well. So that means our function is increasing on the intervals from -1 to 0 and the interval from 1 to infinity. And we have decreasing for our function at -infinity to -1 and from 0 to +1. So here's our intervals where our function is increasing or where it is decreasing. And why don't we verify that by looking at the graph again. So let's go back to our y equals. I'm going to delete our last example. So we have x squared minus 1 in parentheses. And I'm raising that to the 2/3 power. And I can just type in 2 divided by 3. Let me check the window again. So we need to make sure we have -1, 0, and 1 in there, which we should. I'm going to shorten it up just a little bit. And for the y values, why don't we shrink this up a little bit as well? So I'm going to make this from -1, and I will just go up to +5. And let's graph this. And we should be able to see where our function's increasing and where it's decreasing. So as we can see, from -infinity until we get to -1, our function is going down, it's decreasing. At -1, it switches, and now our function is going back up, it's increasing. We have a horizontal tangent line at 0, and then the function is going back down, decreasing, until we get to +1, and then at +1 it switches again, and our function is increasing. So that's how we can determine where our function is increasing or decreasing. Just to outline that process again, we find the derivative of our function. We use the derivative to find the critical numbers. The critical numbers take our domain, split it up into intervals, and then we need to test those intervals to see where the slopes of the tangent lines are positive or negative. And we can do that using the derivative. Once we know where the slopes of the tangent lines are positive or negative, that also indicates where our function is increasing or where it's decreasing.